The only difference with 12.2 is that you have to know the negative exponent rule. All right, and so remember the rule says that if you have a to the negative n power, then what's that the same as? How do you make that, how do you rewrite it so that exponent is positive? 1 over a to the n. Then the other one is this. What if the exponent is negative in the denominator like this? Then how do you rewrite it so that the exponent is positive? Right, so that's just equal to what? A to the what power? N. A to the n power. All right, so we talked about that if the exponent is negative in the numerator, basically you're going to rewrite it in the denominator, and when you change from numerator to the denominator, the sign of the exponent changes. All right, so that's what we talked about. All right, so let's look at this problem. So this is going to be number 29. That's on page 901. So this part here is going to be used with part B, 12.2 part B. And that's on your test Tuesday. So number 29, you have in the numerator, you have this. And in the denominator, you have this. All right, so what would be the first thing you would try and do here? You know, you gotta remember, you gotta use some stuff from the previous section as well, those rules.
Multiply the exponent.
All right, so what property are you using here? What's the first property you're using? There are several, but what's the first one? The power rule. So she's using the power rule with this one. She's gonna get rid of these parentheses first. So when you have a power raised to power, what do you do those exponents? Multiply. So the next step is going to be this. You're going to say, well, that's going to be m to what power? Nope. 20th. Times m divided by m to the 10th. All right, so that's where we are. So you do one step at a time. Okay, now look at what we have here. What would be the next thing you would do at this point?
Excuse me.
There are several approaches you can take here, but what's one? Say something. This is on your test Tuesday. Say it again. Come on, guys. Okay, what would you use a quotient rule with? The power product, you have to have a parentheses involved. All right, now you see what you got to work on for Tuesday, right? Some of you want to try and keep that A and a B in here. What are you going to do? Okay, so if I just look at the numerator, what do I do to that numerator to simplify this? Okay, but what property are you using? What rule are you going to use? You see, you got to know these things. You can use a product rule. The product rule. When you multiply like bases, what do you do with those exponents? You add them. Okay, now you understand what you got to work on, right? Okay? All right, guys. This is Tuesday. Some of you that have a D or an F, you need to make at least a B on this test. Some of you that have an A or a B, you want to try and keep that A or B. My question to you is not helping you right now. All right, so use the product rule. So what's m to the 20th times m? M to the 21st divided by m to the 10th. That's where we are. What is the next step? That's where you use a quotient rule this time. So in the quotient rule, when you divide like bases, what do you do with those exponents? You subtract them. So that's going to be m to the 21st minus 10. And so what's your answer? M to the 11th. Now remember, the directions will say make sure your exponents are positive. So am I done here? Yes. So the answer is m to the 11th. Okay? So you could, so basically really this has nothing to do with negative exponents. It could have, but in this case it's not. So basically all you needed was the previous section. So that tells me that you also need to work on section 12.1. What you turned in today, 12.1. That's what you need to work on as well, because that's all you needed. People, all you needed for this problem was 12.1. You did not need 12.2 at all. All right, so that's 29. Let's look at 32. Okay, 32, you have this. You have p divided by p to the negative third times q to the negative fifth. All right. So what are you going to do? Okay, so you're going to use the quotient rule. Now, in the denominator, you can't use the product rule. See the denominator? Like we did the numerator here? This denominator, you can't because the bases are not the same. But you're going to use a quotient rule, and you can only use a quotient rule if the bases are the same in both the numerator and the denominator, and they are. So I'm going to circle what I'm going to use a quotient rule with. Okay? So I'm going to use a quotient rule with this. Now, I'm going to have this fraction. Now, I'm circling what I'm going to manipulate. What, so far at this point, what am I not fooling with right now? So it's going to stay where it is. Where is it? In the denominator. Okay, now the quotient rule says that when you divide like bases, you're going to subtract exponents. So be careful. It's going to be the top exponent, which is what? Subtract the bottom exponent, which is what? Negative 3. So that's where I'm at. Now, if you don't remember your signed numbers, use your calculator. What's 1 subtract a negative 3? Not negative 4. Positive 4. Okay, so this is where I'm at. All right, so that's where I'm at. So that's where we are. Okay, now, can I use a quotient rule with what I have at this point? No, because the bases are not the same. Okay, but I don't want any negative exponents. Do I have any negative exponents? Yes. Where is it located? Where do I rewrite it? Okay. So what's going to be the answer? Let's put it in alphabetical order. So let's do the P first. P to what? 4th times Q to the 5th. So there's your answer. All right. So that was 32. 34. 34, you have z to the 5th divided by x to the 5th raised to the negative 3rd. All right. What's the first thing you're going to use here? Power of a product. Power of a product. And so remember the way we talked about doing this last time is to, for some of you may want to do this particular step. So each factor that's in that parentheses has to be raised to what power? Negative 3rd. So basically you're saying this. You're saying, all right, I'm going to take z to the 5th. I'm going to raise it to what power?
Negative third.
I'm going to take x to the fifth. I'm going to raise it to what power? Negative third. All right, so remember, to go from here to here, I use the power of a product. Now, how do I deal? Okay, what rule am I going to use with this? The power rule. So that becomes z to what power? Okay, times x to what power? All right, so that's where I'm at. Okay. All right, so to go from here to here, I use the power rule. Okay. Now, what rule do you think I'm going to use next? The negative exponent rule. All right, so let's now notice that there are two factors that have that negative exponent. So let's deal with one individually. Okay. So here's the way I would do this so you don't mess up. Cover this one up for right now. What is z to the negative 15th the same as? 1 over z to the 15th. Okay. All right, let's cover this up now. What is x to the negative 15th the same as?
1 over x.
Yeah. Now remember, what's an operation that's right here that I'm pointing to? Multiplication. So now I have 1 over z to the 15th times 1 over x to the 15th, and all you do is multiply the numerators and multiply the denominators. What's 1 times 1?
1.
And then the denominator is just z to the 15th times x to the 15th. There's your answer. All right. So notice the little steps that we went through. You can easily mess up in some places, so you got to be careful. It's not an easy concept, but it's doable. You can do this with practice. You got to practice on this. You got to know your rules. You got to know the names. Knowing the names does help. All right, 36. All right, in 36 you have, all right, you have this fraction. The numerator looks like this, and the denominator looks like this. What? Okay, so what are you going to do? What's the first thing you're going to do? And name the rule. Nope. The power rule. Power raised to power. The numerator, that's what you have, right? You have y to the fourth being raised to the second power. That's the power rule. So what's y to the fourth times raised to the second power? Y to the eighth. In fact, the product rule is not involved here at all. It's the power rule that's in the numerator. All right, so remember to go from here to here. That was a power rule. Okay, now, what rule? There's only one rule. Well, two rules left. What's the next rule you're going to use? Quotient rule. All right, so the quotient rule. So the quotient rule says when I divide like bases, what are those exponents? So that becomes, and you can do this in your head, but I'm going to go ahead and write it out. So that's y to the 8 subtract what? 12. Now don't say that's y to the fourth. What's 8 subtract 12? Negative 4. So that's where we're at. One more rule and we're done. What's the next rule you're going to use? The negative exponent rule. So what's the answer?
1 over y.
Yeah, so that's the negative exponent rule. All right, so there's your answer. All right, 38. All right, 38, you have this fraction. You have x squared raised to the fifth, x fourth raised to the third. That's what we have. What rule are you going to use first? The power rule in both numerator and the denominator, right? So when I use the power rule, what's going to be the numerator? Okay, when I use the power rule in the denominator, what's going to be the denominator? X to the 12th, so that's where I'm at. What's the next rule I'm going to use? Quotient rule. I'm dividing like bases. So that's going to be x to the exponents in the numerator, which is what? 10, subtract 12. And what's that going to be? X to the negative second. Remember, you don't want any negative exponents. You got to rewrite this. So what rule are you going to use? Negative exponent rule. So what's the answer? Yeah. All right. That's 38. All right. 42. All right, 42, you have this. You have, in the numerator, you have 15a to the 4th. And in the denominator, you have negative 15a to the 5th. All right, let's deal with the coefficients first. What's the coefficient in the numerator? Okay, what's the coefficient in the denominator? All right, so if I cover this up, what's 15 divided by negative 15? Negative 1. All right, so basically you would say this right here, because 15 divided by 15 is 1, so 15 divided by negative 15 is a what? Negative 1. All right, so I dealt with the coefficients first. Now I'm going to cover this up, and now look at what we have left. What rule are you going to use here? Quotient rule. Okay? So do you agree this becomes negative 1 times a to the 4th subtract 5?
Yeah.
All right. So what's 4 subtract 5, though? All right, so look at what we have. We have negative 1 times a to negative 1, right? Okay. Now remember, you don't want your exponents to be what? Negative. So I'm going to have to rewrite. I'm circling what I have to rewrite. I have to rewrite this right here so that way the exponent is what kind of exponent? Positive. So to rewrite what I have circled, what rule am I going to use? Negative exponent rule. So this becomes negative 1 times what? 1 over a. And we're going to rewrite this as just negative 1 divided by what? A. Because look, negative 1 times 1 is what? Negative 1. And the denominator is just what? A. So that's the answer right here. Number, all right, let's look at this one. I'll write this example. Now let's do this, just put this in as an example. Suppose we had y to negative 5th divided by y to negative 2nd times y to the negative 7th.
Thank you.
All right. So given that, what rule are you gonna use first? Yeah, you use product rule where? In the denominator. That's what I would use first. I'll use that first. So what is y to the negative 2nd times y to the negative 7th? Y to the negative 9. Okay, so I have this. I have y to the negative 5th divided by, in the denominator, that's going to be y to the negative 9. All right. Now what rule are you going to use? Not a power rule. Quotient rule. The power rule is where you have to have parentheses involved. There are no parentheses here. So the quotient rule. So I'm dividing like bases. What are those exponents I'm circling? Subtract. So that's y to the negative 5th. Subtract a what? Negative 9. Okay, now you got to remember your signed rules. Y negative 5 subtract a negative 9 is the same as negative 5 what? Plus 9. Good. And then what's negative 5 plus 9? Now negative 4, positive 4. So the answer is y to the 4th. The exponent is positive, so I'm done. You're done because you want the exponent to be positive. Now, if you could remember that subtracting a negative 9 is the same thing as adding a positive 9, use your calculator. You calculate negative 5 subtract a negative 9 and enter. you'll get 4. Okay? So use your calculator if you need to. Okay, 48. All right, 48, you have, in parentheses, you have 5x squared y negative second raised to the second power. Okay, what rule are you going to use here? Power of a product. Power of a product. So for some of you, it may be helpful to write in this next step. So each factor that's inside the parentheses, I'm going to put in parentheses by itself. So what's the first factor that you see? The 5. So 5 has to be raised to what power? The second. What's the next factor that you see? X squared. It has to be raised to the second. What's the next factor that you see? To the negative second. It has to be raised to what power? The second power. Okay? So power of a product says that each factor are raised to that power. Okay, now look at this step that I just wrote. What rule are you going to use next? Not the product. Power. The power rule. Now the coefficient, you know, you can use the idea of the power rule of that, but what's 5 squared? It's just what? 25. Okay. So that's 25. Now I'm going to use the power rule with the variables. So what's x squared squared? X to the 4th. What's y negative second squared? All right, so that's where I'm at. So this is the power rule is what I used. Okay, am I done? Is that the answer? Why not? You don't want any negative exponents. So what's the only variable that's being raised to negative exponent? Y negative. So the y, right? So you can skip this next step, but what would be the answer, do you think?
1 over y to the 4th.
Well, what happened to the 25x to the 4th? Okay, so you see how you're getting different things here. You're not quite sure what to do. All right, so here's probably the best thing to do in the next step. The only thing being raised to negative power is this, correct? So I'm going to circle it for right now. So that's the only one I'm going to move. That's the only one I'm going to rewrite. Everything else stays where? Where it is. So everything else stays where it is. So I have 25 times x to the 4th times, now how do I rewrite what I have circled? 1 over y to the 4th. All right, but you want your final answer as one fraction. What's the numerator of my final answer?
Y to the 4th.
No, y to the 4th is in the denominator. No, okay, so you agree that 25 is 25 over 1, right? All right, so now you see how some of you kind of messed that up too? So then what I would do if I were you, I would rewrite 25 as 25 divided by what? 1. I would rewrite x to the 4th as x to the 4th divided by what?
1.
And then I have 1 over y to the 4th. Now multiplying fractions. When you multiply fractions, you multiply the numerators together. What are my numerators? 25, what's the other one? X to the 4th, what's the other one? 1. So what's going to be the product? Okay, now let's talk about the denominators. What are my denominators? 1, 1, and y to the 4th. When I multiply them, what do I get? In the denominator. That's your answer. That's the answer. So as we were discussing this, and some of you were stating where 25 and x to the 4th were incorrectly, this may be what you might want to do. Okay, so write in that step. Don't be lazy. Write in the step. You have time. Get here at 5:30 and start taking a test. But notice it's difficult to go from the problem to the answer. So you need to do these steps, and remember, rewrite it 25 over 1, x to the 4th over 1. and 1 over y to the fourth, and then remember how to multiply fractions. You multiply numerators together, and then you multiply the denominators together. All right, 46. All right, 46, you have this. You have negative 8x,
Can you bring down a little bit, please? Thank you.
negative 8x, a squared b. That's the numerator. The denominator is negative 5, x a to the fifth, b. All right, so let's discuss each little part here. So I do have coefficients. What's the coefficient of the numerator? Coefficient of the denominator? Can I reduce that?
Yeah.
How? The only thing I can do is the fact that a negative divided by negative is a what? Positive. But 8 divided by 5 is still what? 8 divided by 5. Okay? So I know that in my final answer, my numerator is going to have what number in it? But what number? 8. My denominator is going to have what number? 5. All right, but you see the variables? What if I cover this part up for right now? Let's suppose that the coefficients were just ones. What rule would you use at this point? The quotient rule. All right, so here's the way we're going to approach this. So negative 8 divided by 5 is negative 8, is positive 8/5, right? Okay, now let's talk about the variable x's. So when I divide like bases, what do those exponents?
One.
What do I do with the exponents? Tell me what to do to the exponents. Subtract them. So that's x to the 1 minus what? Minus 1. Now let's talk about the a's. That'll be times a to the second, subtract what? 5. Now let's talk about the b's. That's b to the first, subtract what? 1. So that's where I'm at. Okay? No, I'm just not skipping any steps here. So 8/5, I have 8/5 times x2. Now what's 1 subtract 1? 0. Times, what's a? Times a to what power? Negative 3. Times b to what power? All right, so that's where I'm at. Notice I'm not skipping any steps. I'm doing it one little part at a time. Now let's talk about x to the 0. Do you remember what x to the 0 is? 1. Remember the 0 exponent rule. A non-zero number, the 0 exponent rule. We talked about that, I think, last class period. So a to the 0 power, as long as the base is not 0, anything but 0, that factor raised to the 0 power is always going to be what? 1. And we discussed that. We saw why it was true. We saw that. So if you weren't here, you need to go back in your notes and kind of see what we talked about. Why is a non-zero number raised to the 0 power equal to 1? So this is 1 right here, right? So I have 8/5 times this is 1 times, now what's 8 negative third?
1 over 8 to the third.
1 over 8 to the third. So you were using the negative exponent rule. Times, what's b to the 0? 1. So that's where I'm at. Okay? All right, now, your final answer is gonna be one fraction. You can't leave it like that because you have basically 4 fractions involved here. You want just one fraction. You want to make it simple. You want to look at simple. You make sure it looks simple. So the question to you is this: what's going to be the numerator of my answer? Do you think?
8 over 5.
Okay, someone said 8 over 5. Well, based on what you just said, 8 divided by 5, 8 is a what? Numerator. 5 is a what? Denominator. I'm going to ask you again. What's going to be the numerator? 8. 8 is going to be the numerator. All right. Now, you remember how some of you are still kind of messing this up? You remember how we did this right here where you're messing this part up and we said, well, if you're going to mess that up, then you may want to rewrite 25 as what? 25 over 1. You may want to rewrite x to the fourth as what? X to the fourth over 1. So you see how you're still doing the same thing here. So you may want to rewrite this. So you may want to say, well, 8 to the fifth is 8 fifths. 1 is what? 1 over 1. 1 over 8 to the third. And this one's also what? 1 over 1. And then you multiply the numerators together. What are my numerators? 8, 1, 1, and 1. What do you get when you multiply them? 8. What's the denominator? 5a to the third. So there's your answer. Okay, that would be what you would give. You want your answer as one fraction. All right, but again, notice it helps. It's for some of you, if you do this little last step right here that I'm pointing to. All right, and 40. Okay, we did 46. All right, so that's gonna be part B. All right, so I'm gonna give you the worksheet in part B at the end, but that's gonna be part B, and that's on your test. So make sure. Today's Tuesday. I would prefer if you can have part B for Thursday. So I can give you the key because it's in your test. All right, I wouldn't wait until the day of the test to turn it in. All right, so I'll give it to you. It's not difficult. It's doable. You can do this. So I'll give it to you. Just try and have it for Tuesday. All right. I mean, not Tuesday. I meant Thursday. Okay, so this will be part C. Part C is not in test 3. Part C is going to be on test 4. And so this is going to be part C. So let's do number 50. So this is number 50. Okay, so it still involves all the stuff we've been talking about. All right, but this is what 50 looks like. It's a little bit more complicated. You have this. You have 4 to negative 1 times x to the fifth raised to negative second. It's still doable. You have enough information to do this. What rule are you going to use first? Power of a product. So the power of product, see in the parentheses is product, right? And I'm raising it to a power. So the power of a product says I take each of those factors that's inside the parentheses and I raise it to that exponent. So what's the first factor you see? 4 to the negative 1. What do I raise it to? Negative 2. What's the next one I see? X to the fifth. What do I raise it to? Negative 2. So that's going to be the power of a product. Now, what rule am I going to use next to simplify this stuff? The power rule. Okay, so the power rule. When you have a power, it's a power, exponent to exponent, you multiply them. So what it's going to be 4 to what power? The second, positive 2. X to what power? Negative 10, so that's where I'm at. Okay, now let's talk about 4 to the second. What's 4 to the second? 16. How am I going to deal with that x to the negative 10th? Negative exponent. So that's 16 times what? See, do that step. Don't skip it. First, do the step. 1 over x to the 10th, right? But don't leave it like this because you want to write it as one fraction. So based on what we've been talking about, what do you think the numerator is going to be? 16. Good. What's the denominator going to be? X to the 10th. So there's your answer. That was 50. 52. All right, 52. You have this. Okay, so you have, it looks like this. I'm not going to say the words because some of the words have to do with the rules. So I'm going to not say the words. I'm just say this is what it looks like. All right, 52, you have a to the fifth, b, a to the seventh, b to negative second, all raised to the negative third. Okay, several approaches you can take here. I'm going to try and show you the two main approaches you can take. But let's see what one of them that you might say. Power, well, that's not a product. First of all, when you look at it, it's power of what? Quotient. Power of a quotient, which turns into power of a product. So at some point, you're going to use a power of a product. But the first thing you see is that this right here is a quotient. It's a fraction. So the power of a quotient says this. I'm going to take the numerator, raise it at power, and I'm going to take the denominator and raise it at power. So what's the numerator? A to the fifth. B, it has to be raised to what power? Negative 3. What's the denominator? A to the seventh. B to negative second. It has to be raised to what power? Negative 3. So that was the power of a quotient rule. All right. Now look at what we have now. What rule do you think we're going to use next to simplify this? Power of a product. Power of a product. So both the numerator have a product and the denominator have a product. So the power of a product, and you see I'm doing all the steps. Power of a product says I take each factor and I raise to the exponent. So that's a to the, in the numerator, there'll be a to the fifth, in parentheses, raised to what power? B, in parentheses, raised to what power? Good. The denominator, there's going to be a to the seventh, raised to what power? B to the negative second, raised to what power? All right, good. All right, so from here to here, that was the power of a product. All right, now I stop parentheses. How to get rid of the parentheses now? What rule are you going to use? The power rule. Very good. What's a to the fifth raised to negative third? Okay. What's b? Now remember, that's b to what power right here that I'm pointing to? The first. So what's b to the first raised to negative third? Negative 3, right? The denominator, what's a to the seventh raised to the negative third? 21. What's b to the negative second raised to the negative third? B to the sixth. So that's where I'm at. All right, so that was the power rule. All right. What rule do you think you may want to use next? Quotient rule. So I'm using the quotient rule on the A's. I'm using the quotient rule on the B's. So let's talk about the A's for right now. So when you have a to negative 15th divided by a to negative 21, that's going to be a to, what's going to be the first exponent we're going to write? Negative 15. Subtract what? Negative 21, just like this. Times, let's talk about the B's now. B to the what? Negative 3. Subtract 6. So that's where I'm at. All right, now look at that, at the exponent of the A. What's negative 15 subtract a negative 2 is the same thing as, say, negative 15 plus 2. I'm sorry, thank you, 21. Negative 15 plus 21, which is 6. So that's a to the 6. Y'all agree? Now, if you didn't, remember that subtracting a negative number is the same thing as adding the positive or adding the opposite. Then use your calculator. What about B? No, not B to the third. Negative 3 subtract 6 is what? Negative 9. What? Because you subtract the smaller exponent. I mean, you subtract the exponent from the denominator. What's the exponent? What's the exponent in the denominator? 6. So it's the top exponent. Subtract the bottom exponent. The bottom exponent is 6. All right. Just like we did here. Negative 15 subtract a what? Negative 21. Negative 3 subtract a what? 6. But negative 3 subtract 6 is a negative 9. All right, is that the answer?
No.
No. So what's going to be the answer? What's going to be the numerator?
A over 6.
What's going to be the numerator?
A over 6.
Why? A over 6 means this.
Oh, I mean, A to 6 power.
Okay, so be careful with your words. So A over 6 means this. So they can't be right. So it's A to the 6th power. What's going to be the denominator?
B to the 9th.
B to the 9th. Okay, so there's the answer. Notice all the little steps you have to do so you could get the answer correct. If you skipped any of those, you probably would have had an error somewhere. So it's the point being, it's important you do step by step. And notice all the rules we talked about along the way. Power of a quotient, power of a product, power rule. This was a quotient rule. And this was the, go from here to here, we use the negative exponent rule. So we use a bunch of rules here. All right, so look at all the rules that we use. So we use quite a few. All right, so that's 52. All right, let's look at 56. All right, 56. You have, in the numerator, you have 2 to the negative third. Oh, I wanted to show you the other way to do this. So let's go back. Well, let's do 56 first, and then we'll come back and do 52 again. All right, 56, we have 2 to the negative third times x to the negative fourth divided by 2 squared times x. Don't make it difficult. What are you going to use here? What does it look like, the rule that you're going to use? Quotient rule. Quotient rule. There aren't any parentheses anywhere. So you're not going to use a power rule. You're not going to use the power of a product or power of a quotient because there aren't any parentheses. But I do see the same basis in both numerator and denominator. So that's a quotient rule. So the base 2, let's talk about the base 2 for right now. That's going to be the 2 raised to the exponents in the numerator. What's the exponent in the numerator? Subtract a what? The exponents in the denominator, which is 2. Times x to the, what's going to be the first exponent listed? Subtract 1. Because if there's no exponent there, so this is going to be a 1. So that's 2 to the, now what's negative 3 subtract 2? Negative 5. What is negative 4 subtract 1? Negative 5, right? Okay. So that's where I'm at. Am I done? No. Okay, so again, the best way to do that is to deal with each one individually. What's 2 to negative 5 the same as? 1 over 2 to the 5th times. What's x to negative 5 the same as? So that's where I'm at. Okay? All right, now, what's 2 to the 5th? 32. So that's 1 over 32 times 1 over x to the 5th, right? Now write your final answer. What's the numerator of my final answer? 1. 1 times 1 is 1. What's the denominator of my final answer? Okay, notice how each step helped me to get to that answer. All right, so that was the quotient rule to get to this point. And then here I use the negative exponent rule. All right. So that's 56. All right, 60. Oh, let's do 52. So here's 52. Just to show you how else you could have done this one. All right, so if that outer exponent wasn't there, so we cover the outer exponent, and that's all you had, what rule would you use first? Quotient rule. So in parentheses, I would have a to the 5 subtract what? 7. times b to the first subtract a what? Negative 2. But all that's being raised to what power though? Negative 3. So I could have used the quotient rule first inside the parentheses. So now I'm going to simplify what's inside the parentheses. What's 5 subtract 7? Negative 2 times b to the, what's 1 subtract a negative 2? 3. All that those being raised to what power? All right, so that's where I'm at. Now I need to get rid of this parentheses that's right here. What rule am I going to use now? Not product rule. Power of a product. So the power of a product says I take each of those factors raised to that exponent. So that's a to the negative second raised to what power? Negative 3. B to the third raised to what power? All right, so that was the power of a product. What rule am I going to use now to get rid of those parentheses? Power rule. What's a to the negative second raised to negative third? A to the sixth. What's b to the third raised to the negative third? Negative 9. And so therefore, the answer is going to be what in the numerator? B to the 9. And that's the same thing we had here. Okay? So those are different approaches. Different approaches. So just look at the different approaches you can take here. Okay? And remember to go from here to here, that was the negative exponent rule. All right? So different approaches, got the same answer. All right? Okay, remember to go from here to here, those are quotient rule. So the first rule we used was a quotient rule, then we used the power of a product, then we used a power rule, and then we used a negative exponent rule. All right, then let's do 60. 60. All right, here's 60. The numerator looks like this. That's an S. And the denominator looks like this.
What's the last?
S. R. Okay, negative 15, R to negative 6, S. 5, R to negative 4, S to the negative third. All right, you have enough information to do this. There are no parentheses. Now look at the coefficients. How are you going to deal with the coefficients? What is that? Negative 15 divided by 5, which is what? Negative 3. So you all agree that so far I have negative 3, right? Okay, let's talk about the R's. What are you going to use to simplify that? Quotient rule. So that's R to the negative 6 subtract a what? Negative 4. Remember, it's always subtract. Top exponent, subtract bottom exponent. Times S to the, what's the top exponent? 1. Good. Minus a what?
3.
Not 3. Negative 3. All right. So I have negative 3 times R to the, what's the exponent going to be? Negative 2. Is that correct? So it's negative 6 plus 4. What's negative 6 plus 4? Okay. Times S to the 4th. All right. So just going to ask you, what do you think is going to be the numerator of my final answer? Yep. What's going to be the denominator? R to the second. Now remember, if you can't still get from here to here, then do the next step. So the next step would be negative 3 over 1. Use the negative exponent rule. R to negative second is the same as what? 1 over R to the second. And then S to the 4th is the same as S to the 4th over what? 1. And now I think you can get the answer. Negative 3 times 1 times S to the 4th is negative 3S to the 4th. 1 times r squared times 1 is r squared. So if you need to do this right here, then do this right here. Do that step. But I think most of you now should be able to go from something like this to an answer without doing this step. All right, so that was 60. 62. You have the numerator is r to the negative second, s to the negative third. The denominator is r to the negative fourth, s to the negative third. All that's being raised to the negative third power. All right, there are two approaches you can take here, two paths you can take, but we're going to do just one of them. So you tell me which one you want to do. What's the first step you want to do? Well, okay, you want to use the power of a quotient first, okay? So you could have used a quotient rule first in the parentheses, but she wants to go directly from rewriting this to using the power of a quotient. So that means that the numerator, we put in parentheses, it has to be raised to what power? Negative 3. The denominator, put that in parentheses, it also has to be raised to what power? All right, so that was the power of a quotient. All right, now, how to get rid of the parentheses in the numerator now? That's going to be the power of a product. So power of product says I take each of these factors and I raise it to that exponent. So that's going to be r to negative 2 in parentheses raised to what power? Times s to negative third raised to what power? Okay, so that's the numerator. The denominator is going to be r to negative fourth raised to what power? Times s to the negative third raised to what power? All right, so that's where I'm at. So that's the power of a product. So I still have parentheses. How to get rid of those parentheses? Power rule. What's r to the negative second raised to the negative third? R to the sixth. What's s to the negative third raised to the negative third? Yep. Okay, now the denominator. What's r to the negative fourth raised to the negative third? Yep. And what's s to the negative third raised to the negative third? All right, so that was the power rule. So that's where I'm at. Now, no longer have parentheses, but what rule can you use? Quotient. So let's do the r's. That'll be r to the 6 subtract what? 12. Let's do the s's. That's s to the 9 subtract what? Good. What's 6 subtract 12? Not 6.
She said negative 6.
She said negative 6. Okay, negative 6. And what's 9 subtract 9?
0.
All right, so that's where I'm at. Okay? Now let's talk about r to negative 6. What is that?
1 over r to the 6 power.
Yep, 1 over to the 6. What's s to the 0?
1.
What do you think the answer is?
1 over r to the 6.
1 over r to the 6. Very good. 1 over r to the 6. All right, the more practice you do with this, the better you become. So just watching is not going to help. You got to go back and do the same problems again without looking at the work. Try and do it on your own. So you got to practice with these. You can't just look at it and say, I know it. All right, 66. All right, 66, you have this. You have the numerator looks like this. The denominator looks like this. That's not 66, I'm so sorry. So it's 67, but let's do 67. Let's just keep it. That's 67. The denominator looks like this. It's actually harder than 66, so let's just keep it. All right, so that's where I'm at. So that's 67. What rule are you going to use first? Power, well, yeah, the power of a product. not the quotient. The quotient, you would use the power of a quotient if that fraction's all being raised to the same power. But is that the case? No. Here the outer exponent's -3, here the outer exponent's -1. So it cannot be the power of a quotient. So if I cover the denominator, that's going to be the power of a what? Product. If I cover the numerator, that's going to be the power of a what? Product. So I'm using a power of product in both of those. Now remember, the power of product says I take each factor and I raise to that exponent. So in parentheses, you're going to say -2 raised to my power, -3. Then you're going to say x to the first raised to my power, -3. Then you're going to say y to -3rd raised to my power, -3. Okay, so that's where we are. Let's talk about the denominator. X to the first raised to our power, -1. Y to -1 raised to our power, -1. So that's where we are. Okay? All right, now be careful with that -2. Don't say -2 to -3rd is -8. That's not true. -2 to the +3rd is -8, but that's not a +3, that's a -3. So what I would do first here, is think about it like this. So you see that -2 right here, that's understood to be a 1, right? And all that's being raised to what power? All right, so when I have a power is a power, do what are those exponents? So that becomes -2 to the third, right? I'm sorry, -3, right? Okay. All right. So 1 times the -3 is a what? -3. Okay. So that I would read like this first. So this, because if you use your calculator, and I guess you could take your calculator out. It's no big deal. You can use your calculator with that. I want to show you something. Take your calculator out. You have parentheses, -2, close parentheses, that's being raised to the -3rd power. See what it looks like when I press equal? Get this decimal. But you want to rewrite this as a what, though? Fraction. So second PRB, so you get -1/8. All right? -1/8. So keep in mind that this right here is -1/8. So just keep that in mind. Now, the point here I was trying to make is that if you didn't have a calculator, this is what you have to think about. So remember, when I'm going to use the negative exponent rule here. So that becomes negative, this right here is -1, times 1/2 to what power? The third. And what's 2 to the third? 8. So that's -1 times 1/8. And what's -1 times 1? So you get -1/8. All right? So dealing with this was not easy. That right here was not easy to deal with, but you have a calculator. Use your calculator to help you. All right, so I'm going to keep in the end, I'm going to keep in mind that -2 to -3rd is what fraction? -1/8. Okay, now I'm going to cover this up for right now, right here. How do I get rid of these other parentheses? No, not quotient. The power rule, right? Just like I did this. All right, so here we go. So I'm not going to do anything with this. Well, I'm going to write this as, okay, I'm going to cover this up for right now. I'm going to circle this for right now. And just remember that is going to be -1/8. Okay? So this part here, I'm going to rewrite right here. So that'd be x to what power? -3. Y to what power? 9. X to what power? Y to what power? All right, so that's where I'm at. And remember, this right here is times -1/8, like that. Y'all agree that this is this? Okay. Now look at this right here. What I'm going to use here to help me simplify this, quotient rule. So I get -1/8 times x to the -3rd subtract a what? -1. Y to the 9 subtract what? Good. So I get negative 1/8 times x to what power? Negative 3 subtract negative 1 is what? No, not negative 4. Come on, you say negative 3 subtract negative 1. Use your calculator. It's negative 3 plus 1, which is what? Negative 2. So if you're not proficient with signed numbers, use your calculator. You have access to a calculator, use it. Y to the what? All right, and so then we just kind of do it like we did before, one step at a time. So that's negative 1/8 times what? 1 over x squared times y over 8 divided by what? 1. Very good. So therefore, what's the numerator of my answer? But don't forget there's a negative 1. So negative y to the 8, right? Over what?
8 to the x squared.
8x squared. Okay? Now, another way you might see the answer written, 67. The other way you might see the answer written is remember we talked about this before? Negative 7 divided by 6 can be written as 7 divided by negative 6. Or you can write it as 7/6 with a what in front of that fraction? A negative. So the way that if you were to look at the answer in the back of the book, the odd numbers are in my math lab. In my math lab, you could leave your answer like this, or you can put it as y to the 8th divided by 8x squared, and what in front? Negative. Okay, so either one's fine, though. Does not matter. Does not matter. Now that one was difficult. That was not an easy one to deal with. You could have easily messed up anywhere, but you, if most of what you wrote is correct, you'll get most of your points. You probably would have messed up with the coefficient, because that was an easy one to mess up with. All right, now that one was an easy one. That was a difficult one. Now, the one in your test is not that complicated. The one in the final is not that complicated. But you do have more worksheets, because the worksheets you have more time to work on it. But the test is not going to be that complicated. All right, let's look at 70. Let's do one more. Number 70. All right, 70 looks like this.
Bring it down just a little bit. Sorry, thank you.
The numerator looks like this. And the denominator looks like this. Now that you could probably see on a test. It's not that difficult. That one's not difficult. The previous one was difficult. But this one's not. What's the first step you're going to do? First rule? Power of a product. Power of a product. So the power of a product says I take each factor that's in the parentheses, I raise to that power. So that's a to 6 raised to that power. 4. B to negative second raised to what power? 4. And then the same thing with the denominator. 4 raised to what power? Third. A to negative third raised to what power? Third. B to the negative third raised to what power? Third. Okay? So that was the power of a product. Now let's get rid of the parentheses. What rule am I going to use next to get rid of those parentheses? Power rule. So what's a to the 6th raised to the 4th? A to the 24th. What's b to negative second raised to the 4th? Very good. What's 4 to the 3rd? That one you can do. It's not like negative 2 to the negative 3rd. 4 to the 3rd, use your calculator. 4 times 4 times 4 is what? Where is that located though? In the denominator. What's a to negative third raised to the 3rd? A negative 9. What's b to negative third raised to the 3rd? All right, so that's where I'm at. Okay. Now let's talk about so not only have parentheses, but what rule do you think you use next? Quotient rule. So the coefficient stays where they are. What's the coefficient in the numerator? Tell me the coefficient in the numerator. 1. Coefficient in the denominator. All right, so do you agree I can write this as 1 over 64 at this point? Okay, now let's use a quotient rule with the a's. There'll be a to the 24, subtract what?
9.
Not 9. Negative 9, got to be careful. B to the negative 8, subtract what? Negative 9, good. All right, so that's where I'm at. 1 over 64 times a. What's going to be that exponent? 24 subtract the negative 9. If you can't do it in your head, use your calculator. What is it?
15.
No. Use your calculator then.
33.
33. 24 subtract the negative 9 is 24 plus 9. That's 33. Use your calculator, guys. And b to what power?
No, it's just gonna say, it's gonna be blank, but it's just gonna be.
No. Oh, yes, you're right. You're right. You're right. Thank you. I'm sorry. I apologize. I was
You was thinking something else.
no, I was thinking negative 1, but it's 1 because that's negative 8 plus 9, which is 1. So that's b to the first. But remember, we don't say b to the first. We just say what? B, and that's what you were saying. Thank you. All right, I don't have any negative exponents, right? But I wanted you to write this as one fraction. What's the numerator? A to the 33rd times b. What's the denominator? There's your answer. Okay? Still a lot of steps, but it's doable. A lot more doable than the previous 167. So that's basically going to be what part C is going to look like when you get it Thursday. But that won't be due until after the test. All right, now there's one more part in this section that has to do with scientific notation. So this is still section 12.2, but we're going to talk about scientific notation. Scientific notation. Okay, 709. All right, so let's go ahead and stop here.